In this lecture, we will discuss how to determine the rate of different types of rhythms. When determining the rate of a rhythm, we can talk about either the atrial rate, which is the frequency of the P waves, or the ventricular rate, which is the frequency of the QRS complexes. Generally, we will find the ventricular rate as they are often most visible, and we will do that here. So you can also apply these principles that we'll go over with the P waves to find the atrial rate as well. Now, one thing to be aware of is that we'll use the R to R interval for determining the ventricular rate, and then you can use the P to P interval for determining the atrial rate. So just to review our P to P intervals from one P wave to the next P wave, we call that our P to P interval for finding the atrial rate. And then we can use the R to R interval, so this R wave of the QRS complex to the next one, that R to R interval to find the ventricular rate. Okay, why ventricular? Because this is the QRS complex that represents ventricular depolarization, and our P wave represents atrial depolarization, so that's our atrial rate. Okay. So when determining rate, you should first determine if you are dealing with a regular or irregular rhythm. You don't need to do this, although it will be helpful as we go through these various ways in determining rate. So let's find the regularity of these rhythms below. So first off, remember with regularity, we're going to look from one R or one interval to the next, and we're going to look to see if they're regular or not, okay? And we'll use the R waves here. So from one R wave to the next, okay, and if you were to measure it out, you'd see that all these intervals would be the same. So from this R wave to the next, from this one to the next, so we would call this a regular interval. So this first, or regular rhythm. So this is a regular rhythm, and the next one, on just initial glance, it looks quite regular as well, right? Here's one R wave to the next R wave, okay? And then we'll measure from these ones, all right? And if you were to measure these out, all of these would be the same throughout, okay? And again, this is a regular rhythm, okay? So the first two are regular rhythms. And then this last one here, notice that this first wave from this to this is our first R to R interval is different from the next one, okay? So these are different, and then it varies throughout, okay? Notice this is much larger than that, and so forth. So you can see these various R to R intervals. So this is an irregular rhythm, okay? And this one's actually irregularly irregular, okay? And one of the most common ones was AFib. So this is an example of AFib. All right, now that we know the regularity of these rhythms, let's see how we can find the rate. The first method we'll discuss can generally be used for both irregular and regular rhythms, regardless if they are fast or slow. First, you should know that the standard 12-lead EKG represents 10 seconds in duration. Next, all you need to do is count the number of complexes. We'll use the QRS ones, okay, the most visible ones, and you count them going across the rhythm strip, and then you multiply that number by 6 to get an estimate of rate in beats per minute, okay? So again, let's just erase some of this stuff here so that we can go through them, and we can use this first method with both irregular and regular rhythms, okay? So remember, these are rhythm strips taken off a standard 12-lead EKG, and what you should know is that from the beginning, the start of the EKG, all the way to the end, it represents 10 seconds. So if you multiply that by 6, you get 60 seconds, which is 1 minute, okay? So if we count the complexes going across and multiply it by 6, we can get the beats per minute, okay? So let's do that here. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So 12 beats going across, so we would do 12 times 6, and 12 times 6 is 72 beats per minute. Now the actual rate here was actually 68, okay, beats per minute on the EKG machine. So again, quite close. We got a pretty good estimate. Let's try the next one. Okay, so again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 complexes going across. So we do 18, and then we multiply that by 6, and that gives us 108 beats per minute. All right, and the actual rate here was 105 beats per minute on the EKG machine. So again, quite close, a great estimate. All right, let's try this last one. This is our irregularly irregular rhythm, and if we look here, count the complexes. There's one here in the beginning, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so this is a faster rhythm. So we do now, I guess, 21 times 6, and 21 times 6 is 126 beats per minute. Okay, and the actual rate here was 128 beats per minute. So again, very close estimation. All right, so as you can see there, it's not too difficult to find the rate. Now the next method we can use only with regular rhythms. Okay, so again, here we're going to use the R to R intervals, and we'll do this by finding the R wave, okay, that falls on one of the thick lines, and then we're going to find the next R wave, okay, and after we do that, we're going to count the number of thick lines between those R waves, and then take that and take 300 and divide it by that number of thick lines that we counted to get the estimated rate, okay. So again, remember, R to R interval is this one R wave to the next, okay. So again, regular rhythms we're using this with, okay? And let's imagine, for instance, we have an R wave that's on this thick line, okay? Thick lines as in these ones, okay? Notice the thick ones that have 5 small boxes between them, okay? So we have the first R wave falling on this thick line, and then we'll find the next R wave. Imagine it fell on the next one, okay? So if it fell right here, we know that there's one thick line, or one of the large boxes between them. So what we would do is 300 over 1 would be 300 beats per minute. So that would be a rate, okay? If the R wave fell here, away from that first one, that means the rate would be 300 over 2, which is 150. If it fell 3 thick lines away, okay, 1, 2, 3, we would do 300 over 3, and we'd get 100, all right? If the R wave was starting here, and that next R wave fell 4 thick lines away, 300 over 4 is 75. If it was 5, it'd be 300 over 5, which is 60, and so forth. Okay, you can start to get the point here. So let's try some examples. Remember, we can only use this in regular rhythms, so we're going to only do that with these first two here. Okay, so let's just erase some of this stuff so that we can see what's going on here. All right, we're going to focus on the first two because these are our regular rhythms. Okay, so let's again find an R wave that falls on a thick line. Let's use this complex here. Notice this R wave falling on that thick line. Okay, next we're going to find the next R wave. Okay, so here's the next complex. That would be this point here. So now we're going to count the number of thick lines between them. Okay, so it's 1, 2, 3, 4, 5. Okay, closer to 4, but still greater than 4. So what we would do here is 300 over 4 is 75, okay, but it's a little past that. 300 over 5 is 60, all right, so it's between 60 and 75, but it's closer to the 75 point, okay. The actual rate here we said was 68, okay. So again, hopefully that makes sense. Let's try the next one. Okay, so what we're going to do here is find an R wave that falls on one of those thick lines. Okay, so let's use this one here. Here's an R wave falling on this one. All right, find the next R wave, which is this point here. So what we'll do is now count the number of thick lines between them. 1, 2, and it falls on the third one. Okay, so what we do here is 300 over 3 is 100 beats per minute. Okay, and what we got here was actually 105. So again, good estimate that we're getting here. Okay, hopefully this is making sense. Now some suggest simply memorizing the 30, 150, 100, 75, 60, 50 and using them. Okay, I don't know how that's much easier, but really whatever works for you. Okay, now one last method to determine the rate of a regular and fast rhythm is by counting the number of small boxes between the P to P or R to R intervals, and then you take 100 or 1500 and divide that by the number of small boxes that you counted between those intervals. And this method can be accurate, although I'm not sure it's the most practical of these here. Okay, I'm not sure I used it too much. So again, as you take 1500, you count the number of small boxes between this, so we can use from here to the next one, count the number of small boxes between that. Okay, again, this is, and then you would do 1500 divided by that. But again, we use it with fast rhythms, so you'd want to use it probably with this second one here, not the first one. Okay, so again, it's more accurate. I don't really see it used too often. The main one that you want to use for both the regular and irregular is this first one here. All right, let's briefly review what we discussed before we end here. So again, the rate, we can talk about atrial or ventricular rate. When we use atrial rate, okay, we're looking at the P waves in the P to P interval. When we look at ventricular rate, we're using the QRS complexes, okay? We're using the R to R interval here, but you can use any portion of the QRS complex, okay, as long as it's consistent throughout. Now, we said with the regular and irregular or fast or slow rhythms, you can use this method where we know the duration of the EKG represents 10 seconds. So if you multiply the number of complexes that you got by 6, you can get the number of beats per minute. Okay, and we saw that. We mentioned the second form where you can use with regular rhythms, is we simply take and find an R wave that falls on one of the thick lines, and then look for the next R wave, okay? And then you divide that by the number of thick lines or those big boxes between them, and that'll give a good estimate. Again, with regular rhythms only, all right? And this last one was with the regular and fast rhythms, where you take 1500, divided the number of small boxes between those intervals, the P to P to R, and that'll give you a good estimate of the rate, okay? Remember, these same things that we were discussing for these R to R intervals can be applied for the P to P intervals. So from this P wave to this P wave, you can count that and get the atrial rate. Well, that's the end of this lecture. We discussed how to determine the rate of different types of rhythms. I hope you learned something.